Then there's, optimization systems, which search options for what to do, the expert systems, which was actually some of the original AI, in the 60s and 70s, was expert systems that used expert rules to decide what to do. And that's all fantastic. But what I mean by autonomous AI is when you combine those things with machine learning, you can get more human-like decision-making capabilities.
Welcome to the Unleashing AI podcast. I'm your host, Pavel Fakanov, and joining me today is Kence Anderson, the Director of Autonomous AI Adoption at Microsoft. And Kence has worked at Microsoft for nearly 5 years in different roles, including Principal Program Manager for Machine Teaching Innovation and Principal Program Manager for Microsoft AI and Research. And before Microsoft, he actually was the founder of Optimize, a targeting recommendation engine for the 50 billion pragmatic advertising space, and is the author of Designing Autonomous AI. And Kence, welcome to the podcast. Super excited about having you today.
Thanks a lot, Paul. It's really, really good to be here.
Likewise. So I know I just given you introduction, but if you don't mind, can you just tell our listeners, how would you describe yourself, basically?
Yeah, absolutely. I think I have a little bit of a non-traditional background for an AI or autonomy expert. I was trained in mechanical engineering, but then spent my entire career in software, mostly at startups, as you say. And the last startup that I worked at was one called Bonsai, which was a platform for building and deploying autonomy, usually in industrial contexts. And that startup was acquired by Microsoft in 2018, where I spent 5+ years working on where autonomy or how autonomy is best used in industrial contexts. We think of autonomy and we think of autonomous cars, autonomous driving, maybe something like drones, which we certainly did work on at Bonsai, especially in the aerial autonomy side. But imagine something like in a factory or in a mine. There's all sorts of equipment that is very complex to operate. Whether that's a wind turbine, a farm might have 20, might have 50, might even have 100 wind turbines that are very complex pieces of machinery, is really difficult to operate. And so one of the things that I realized and we realized was that humans are taking years and decades to learn how to operate, these complex pieces of equipment, and they could use help. I first thought that people would think, and businesses would think that, autonomy is scary in these industrial contexts because people are going to be replaced. But actually, that's not how people felt. I rarely ever heard anyone saying that. I almost always heard people saying, I would really like something autonomous, something skilled that can sit next to, my operators, or help train my operators, help them learn how to do this in 2 years instead of 7 years, or 10 years, that kind of thing. So it's actually been really exciting.
Yeah, it's a really good point. I think like most people actually scared that AI gonna replace like a lot of jobs, but in most cases, most people maybe don't realize it's actually working as a co-pilot. So it just helps like a lot of people just become way more productive and maybe mitigate some mistakes they actually could have done without having that assistance from, let's say, AI that actually saw like a lot of different use cases.
Exactly right. It's been demonstrated in research. Researchers that took chess players and had chess players play against AI and teams of chess players, where there's a chess player working together with an AI, playing chess players and AI, and the clear winner over both AI and human chess players were those teams. And I think that's what we're going to really be seeing a lot of in the future.
Yeah, definitely. And I think we're going to chat a lot today about autonomous AI, about AI agents. But before actually diving into that conversation, I think it would be ideal just to define basically what it means, autonomous AI agents. So we are actually on the same page.
Yeah, that's actually a really great point, because I actually don't like the word autonomous as much. The market has spoken, and I wrote a book about autonomous AI, so I've adopted it. But the English word autonomy kind of suggests that it's off doing something on its own, which is not necessarily the case. I define autonomous AI as as AI that's sensing and responding in real time to optimize or control a process or an equipment. So, it might be a bulldozer, it might be a drone, it might be a CNC machine, but there's always this idea of sensing, perceiving what's happening, and then acting to do something about it based on that feedback. And so you might say, well, an engineer might say, well, we've been doing that for hundreds of years. That doesn't require AI. A PID controller, which was invented in 1912 by the US Navy, responds to feedback. But it's using, and it's very good at what it does, but it's using mathematics to basically decide what to do. Then there's, optimization systems, which, search options for what to do. The expert systems, which was actually some of the original AI, in the 60s and 70s, was expert systems that used expert rules to decide what to do. And that's all fantastic. But what I mean by autonomous AI is when you combine those things with machine learning, you can get more human-like decision-making capabilities. So let me give you an example. When I worked with Bell Flight, the folks at Bell Flight makes drones and helicopters. They make the V-22 Osprey, which is a plane that, turns its rotors up and takes off like that. And they've been doing autonomy for a very, very long time, long before deep learning. But traditional aerial autonomy, like imagine an autopilot, requires GPS, and calculations based on GPS. But what if GPS is blocked? Imagine in the future an aerial taxi, and the GPS might be blocked by a building, or you might be out in some remote area delivering something. In that case, you might need to avoid obstacles or land by sight from a video feed from a camera the way a human pilot would. Now, that's not something that a traditional controller optimization system can do. But autonomous AI, or AI that can take in a camera feed and maybe identify a landing zone and say, okay, the landing zone is here, and here are some of the characteristics of the landing zone, and then control the drone in a way to avoid an obstacle on the way to the landing zone or land on that landing zone. That's more human-like, control and decision-making. And that's kind of one of the things I call autonomous AI. But I will say one more thing. 60-70% of the autonomous AI that I've ever designed for major corporations and institutions is not intended to operate on its own. It's intended to assist, advise, maybe someone on a factory line. It's intended to do a specific job at a specific time, and then maybe hand over control, those kind of things. So I agree with you that it's good to kind of level set what we mean when we say autonomous and autonomous agents. I mean, agents are things that do things in the real world, and autonomous, I'm going to say, equals more human-like decision making.
Yeah, makes sense. And I think a lot of people actually get confused because, let's say, after release of Baby AGI, after GPT, all of these recent tools, they get an impression that we're like at AGI, basically point of time. So it's like completely automated. AI makes all of the decisions. But if these people actually try to use basically Baby AGI or after GPT, it still makes a lot of mistakes. You cannot call it at this point, let's say AGI, or I would even not call it, let's say, autonomous AI, because it still requires a lot of human input. You still need to modify the behavior of AI agents like a lot of times. You cannot completely automate.
Yes. No, there's a couple really good points you're making. There was a great post on LinkedIn by the CEO of Cruise where he was showing the performance of Cruise autonomous vehicles in comparison to humans. Now, it's very interesting because with AI, we tend to, one, anthropomorphize it, and think of it as, something human, which really draws us. But that, beside that, and our love for science fiction, which I do too, kind of tends to draw us towards, thinking that it's, sentient or conscious. But we also tend to compare it to perfection. And so every time we see a crash on the news of a self-driving car, we go, it's doing terrible. It's like, no, hold on a minute. Is that what we do with human beings every time we see a crash on the side of the road? And it was actually very interesting because it showed that in 3 different kinds of scenarios, crashes in general, crashes where the driver's at fault, and there was a third scenario. I can't remember exactly which one it was. In all three of those, the crew's, according to their data, the crew's autonomous driving AI drastically outperformed humans as far as avoiding crashes, up like 90%, 70, 80, 90%. So the first is, we got to have reasonable comparisons when we're talking about these things. The second point that I think you're making, which is really good, is you have to understand a little bit of what you're dealing with. So let's take AutoGPT, for example. If you're talking about an agent that's based on a large language model is basically feeding the entire internet, into an AI and saying, identify patterns and learn what you can learn. Now, that kind of autonomy or that kind of agent should be trusted for things that you would trust asking the internet for. So, for example, when we're getting driving directions, I totally trust Waze. Waze is, crowdsourced, kind of ask the internet type of directions, and it's actually very good. Now, there's a bunch of things that I would not ask the internet and then take the answers at face value because it requires very specialized expertise. Things like working in a factory, or even something like driving a commercial semi-tractor trailer truck. You have to get a special license for that. It takes so me as a person who is on the internet is not qualified to tell you how to do that because I don't have a Class B license in the United States. So I think it's really important for people to understand, if you're talking about travel reservations, AutoGPT is going to be amazing because that's something you can totally ask the internet for. How should I plan my trip to Dubai? I see you living in Dubai there. How should I structure my vacation in Tuscany or whatever? But how should I fly a commercial plane? No, not so much.
Yeah, makes sense. And I think it's a really good point because most people actually don't really understand how these agents work. And because of that, they don't really have the right impression what should happen and which agent you actually can trust, because they just think about it as like AGI, it's basically something that already knows everything and they don't really know what's happening under the hood. And I really like what you mentioned about basically the way AutoGPT works. So I think a really important point here is basically understanding how it's working under the hood, that basically have a separate agent that basically making a decision. What tool should I use? In case you're talking, let's say, about React framework, just for simplicity, it has like a bunch of tools. And during each turn, it just decides, okay, what's the most suitable tool that I actually should be using? And the output it's actually getting from the tool. It's not just creating something on its own.
Yes, that is totally true. And it's a great point. I have been thinking about a kind of quadrant for autonomy capabilities that is based on two axes, where one axis is how high value is this? How much potential reward is there to making this decision well? And the other axis is how much is at risk if you make this decision incorrectly. And the things that go in the four quadrants are basically different kinds of decision-making technologies. So if you're in that bottom left quadrant, which is low value decisions, but also low risk decisions, that's where you can use something like robotic process automation, RPA. You're talking about highly repetitive tasks, where each decision is of low value. It doesn't mean that the prospect of making the decision is low value, but there's also very little to risk. That's where simple rules-based decision making that goes with RPA is totally fine. To me, in my opinion, something like AutoGPT belongs in the top left quadrant, where very potentially high value decisions, but lower risk. That's what a travel agent is. Maybe a restaurant concierge is. Sure, there might be a risk I might have a bad meal, but a meal that I don't enjoy as much, but it's nothing like making a bad decision in a steel mill or at a wind farm or something like that. Now, that high risk, high reward, that's what I've spent most of my time working on, kind of industrial autonomous AI, where it's extremely high value, but also and people's lives could be at risk. If you don't operate things well in a steel mill or in a mine or in a manufacturing or even flying a drone, and those are different kinds of technologies. Now, I do want to say something about what the technology industry and the AI and AI practitioners tend to get wrong. It is totally true that you need to understand what's happening under the hood to some extent in order to make those decisions right. Like, for example, which quadrant should I be in, and am I using the right kind of autonomy? But the industry has kind of jumped all the way to that means you have to be an expert in the lowest of the low-level algorithms and, talk in very AI specific terminology. And it blocks business owners and non-AI practitioners from being able to understand what you're even talking about. So I think it's important to understand how much you need to know about these things. And there's also this aspect of a translation layer. I mean, to be honest with you, most of my work over the past 5-6 years has been as a translator, talking to AI practitioners and having them speak in very specific technical terminology, and then going and translating that into, the English language so that business folks can understand. Because I don't want business practitioners to think that they need to, get advanced degrees and become experts in the kind of terminology that you hear, discussed, at the low level of, AI algorithms, how they work. You don't, but you can't go without that base level knowledge of what each technology is and why it's good at doing certain things.
Yeah, Kence, I really love that idea about the quadrant. So when you're actually understanding about high risk, let's say high reward, what it actually can bring to your business, what's the risks you're actually taking when you're making that decision. And I think I definitely would love to learn more a little bit about different autonomous AI agents applications you have seen in different businesses. So we can just get a sense how we actually can apply it. What kind of ROI can we expect from applying it? All of that.
Great question. So first, I'll just give you a couple rules of thumb that I use when I'm evaluating, when I'm in a business and a business brings me in and says, Kence, first I want you to help me decide what the best use of autonomous AI is, especially the first project that we're going to work on together. And I have a couple rules of thumb on what to look for. And then I'll give you a few examples, or I'll probably give you a few examples along the way. One thing I look for is human beings. So in a factory, for example, if a human being is there operating the equipment, it's usually because you have not been able to automate it completely in any other way. I went to this chemical plant where they use an extruder. An extruder is basically a machine that takes a material, heats it up, and then forces it through some sort of slit or orifice. It's used to make soap, food, films, like that are on your computer display. And this was a place where they were making films for your computer display. This piece of equipment is as big as a football field. Big as a football field takes 7 years to train and certify, to make the decisions in the control room. Very complex equipment. And I said, okay, what are these operators learning to do over the 7 years? And it turns out that the steady state operation, so when the product is being made correctly, the control system inside the machine does everything for you. But when you change products, so when you're going from product A to product B, you have to turn the knobs on the machine until it comes out right. And they will actually send the product to the grinder until that happens. And it could take anywhere between 2 hours to 47 hours to get that right. And no one is ever able to automate that. And that's what the humans are doing there. So I always look for situations like that. There's also situations where folks will say, like I worked at on an application for a cement making plant. So one of the first things you do in making cement is you heat up limestone in a kiln. It's this very, very, very hot industrial oven. So I said, okay, well, what are the operators doing here? And they said, well, there's an automation system that controls the oven down below, but that automation system needs to be directed. And one of the things you need to do is you need to perceive what kind of combustion is happening by looking at a flame. They're looking at the size and shape of the flame, or even the color. So depending on what's being burned in that kiln, the flame might be white or blue or red or orange or yellow. And then you have to look at the haziness of the image in the oven. So the operator looks in there, perceives that, and then directs that automation system by creating a set point. That's very, very common, this idea of a set point, which is giving direction to an automated system based on something you're perceiving or a strategy that you need to enact. So when I see that, that's a dead ringer for autonomous AI is going to be able to help, because autonomous AI, it can perceive that flame, categorize maybe different types of combustion based on pattern matching, and then make a decision based on it. So that's the first thing I look for. What are the humans doing? And is there some aspect of human decision making that autonomous AI can actually now do and help out with? The other thing that I look for is where folks say, yeah, everything is great except when, and they start listing specific hard conditions, or they say, well, things change over time. So there was an application where you're making pieces of electronics, like, for example, mobile phones. As the case is being manufactured, it's moving along a conveyor belt, and then a robotic arm grabs it, and a door opens, and it's placed in a CNC machine where it's going to get cut as part of the next part. And it works perfectly as long as the case, the work in progress, is sitting in the fixture exactly the way it's supposed to. But if it's slightly tilted, and I mean very small amounts, if it's slightly tilted, if it's slightly up or down or side to side, then the robotic arm will drop it on the way. It'll miss because these things are programmed very rigidly, point to point. They're programmed for exact, precise instructions. And autonomous AI, just like humans, is able to learn by practicing and adapt and say, well, let me practice trying it this way. Let me practice trying it this way. Practice trying it this way. And then it's able to learn how to do. Now, that doesn't mean that it can do everything that a human can do on that assembly line, but it is able to adapt to more conditions than this rigidly programmed.
Yeah, really love these examples. And I think really important point that I would like to emphasize here that you mentioned is basically, in case you're talking about autonomous AI, many people have misconception that I can use it to solve, let's say, 100 different tasks at the same time. Examples that you actually mentioned, we're trying to solve one really simple task, but we do try to do it really well. So we're not trying to solve 100 different tasks at the same time, but we are focusing on one valuable task, and we're doing it really well.
Yes. That is one of the reasons why I'm not confident that we even need AGI to provide value with autonomous AI, because most of what humans are trained to do in industry anyway is something specific. And so an operator that makes plastic in a thermal reactor doesn't know how to control a pharmaceutical manufacturing process. A driver of a semi-truck that delivers goods across the United States doesn't know how to fly autonomous drones, nor do they need to. So we don't even expect that of humans. But let me give you a couple other examples of use cases. So controlling HVAC systems. So in your building there, you live in a skyscraper there, there's a series of chillers or air handler units probably sitting, on top of the building, and they're controlling the cooling, in your building. That is a huge percentage of even global energy consumption. I believe it's half of all energy that's consumed in buildings is consumed by the HVAC system. So that's a big percentage of, carbon that's put in the atmosphere. So I started having folks ask me, including, Microsoft itself, ask me, well, can we use AI to control these chillers? Because these mechanical engineers that are operating these chillers are responsible for dozens and even hundreds of specific set points. And even though they have the capability, they don't have the time to do that and adjust that. Plus, there's a lot of complexities because, there's weather changes, not just short-term changes, but patterns that are changing over time with climate change. Humidity changes things. There's many, and the occupancy, people coming, the patterns of people coming in and out of the building. And when I saw that pattern, that, people leaving, let's just say even pre-pandemic, people leaving and coming to work at different times based on commutes and things, those are the kind of patterns that machine learning can do really well at. So we designed and we built some AI and installed them in buildings on Microsoft campus, and they're still there, saving greater than 20%. At very least, we saved 20% energy efficiency over multiple years. And in some cases, we save more than that. And we've done that, with other companies. And so I think there's also this aspect of people are really afraid of autonomous AI. They're afraid of AI. AI is going to be used for evil and, terrible things. And it will. I mean, just like the internet's used for terrible things, just like, databases are used for terrible things. Like every technology is going to be used for terrible things because that's about people, not about the things. But to me, the only way to make sure that AI and autonomous AI gets used for anything good is to go out and do something good with it. So, I'm proud of being able to say that we've saved energy, and we're not the only people that have used autonomous AI to save energy. And I'm glad about that. And I think there's going to be a lot of other kind of applications, whether it's more efficient factories, whether it's, saving water in farms. I had a government agency come to me and say, can we use autonomous AI to make sure we use the minimum amount of fertilizer that we need, and that we use the minimum amount of water that we need to increase these crop yields? And the answer was yes. But the challenge, as with a lot of AI applications, is you have to have the data. If you can't find enough data that's in the right format in a way that will kind of simulate and give the AI some feedback on whether it's doing the right thing or not, it can become very difficult. That's the exciting part. I've worked on vertical farming applications where folks have said, okay, we're farming, strawberries and different things in these vertical farms. Now, the great thing about a vertical farm is it's like a factory. It's an indoor farm where they're using hydroponics and various things to deliver the right nutrients and the right water. And so now you're dealing with a situation where you can easily get the data and measure what's going on, and you could make a big difference in the yield of farms.
Definitely. In case I really love all of these points, and in case I would have to, let's say, create a playbook for a business that actually looks to implement autonomous AI, I would say, first, you really need to define a task that you're actually trying to solve. And it should be one well-built task instead of solving 100 different tasks at the same time. It's better to start simple first. After that, you really need to understand what's actually happening. So you basically need to become an agent. So what's the process here? What tools I actually can use? What's my plan? What's basically a step-by-step process? And in that case, you're talking about, let's say, building the basics, building, let's say, the first version. But in case you're talking about, let's say, productionizing our solution, it's really important to understand what kind of data we actually need. Because in building AI systems, data is actually the key. You really need to collect a lot of data, and you have to think about it from the very beginning. And look, I think I could have asked like 10 more questions, including challenges, like problems utilizing autonomous AI. But I think we're running out of time, and maybe I would like to ask a few final questions just to summarize it and finalize it. If you don't mind, can you imagine, in case you had a chance to invite anyone from autonomous AI space or generally from the AI space for lunch, who would it be?
That's a good question. There are a variety of early AI heroes that are still active and still alive that I think is really interesting. Even previous to neural networks, like while first of all, it would be just completely amazing to sit down, for example, with Jan LeCun and talk about neural networks and where things are headed, with deep learning. But even previous to that, some of the early pioneers of expert systems, someone, for example, that I was able to do some work with at Microsoft, Eric Horvitz, the chief science officer. It's so interesting to me, the folks that spent time in early AI but also deeply understand, deep learning and where things are going. I think it's fascinating.
Definitely. And Kence, it's a lot of insights, a lot of really valuable information. And I specifically liked the idea about the quadrant and different applications, how you actually can leverage autonomous AI. And really appreciate you sharing all the knowledge, all the expertise with our audience.
Of course. Thanks for having me, Pavel. It's really nice being here.
Likewise.
The Unleashing AI podcast is brought to you by Unleashing AI. To find out more about Unleashing AI and how innovative, custom-built AI can help your business, visit unleashing.ai. Also, make sure to search for Unleashing AI in Apple Podcasts, Spotify, and Google Podcasts, or anywhere else podcasts are found. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Unleashing AI, thank you for listening.